Hello viewers, welcome back to our YouTube channel 3D Parametric Solid Model Drawing. Today we will create an AC motor in Siemens NX software. In this video, you will learn the full modeling process of this model. If you want to get the file of this model, I have given the link address in the description of my video. By visiting that link, you can get it easily. Okay, alright. So let's start the tutorial. Now this is an inch part file. And set the location of the part in the following way. Save the part in the AC motor folder. And click OK. Set the name of the file. Okay, alright. Now this is our design window of Siemens NX. Now activate the PMI preference command from here. And set the value 5 under the decimal places input box. And click OK. We will pick up the sketch tool from here. In the sketch selection area, we will select the XZ datum plane to start the sketching. Start the horizontal line from the center part origin. Now draw a vertical line and a slanted line from this point like this. Okay. Its length will keep 2.854 inches. Now activate the dimension tool and select this one and this one and fix the dimension 3.858 inches on here. Now draw another line from this point. Okay. And select this point and this point. Fix the dimension 3.3464 inches on here. Set the angular dimension 135 degrees between these two lines. This horizontal line length will keep 12.007 inches. Now pick up the offset curve command. Set the offset distance value 0.118 inches. And select these three lines here. Take the offset inside from the sketch. Now convert this line into reference geometry. Draw the line between the end point of these two lines to close the sketch. Draw the vertical line over the opposite side and fix the collinear constraint between this line and y-axis. Apply the dimension 0.9842 inches over this line. And this dimension is 0.07874 inches. Now we will create some more lines with the given dimensions, something like this. We will delete this internal line and fix the coincident constraint between the end of these lines. Okay, create a line on here and fix the dimension 0.3937 inches between these two lines. Take the offset of these two out and inside lines. Okay. And extend this vertical line on this horizontal line. Erase the extra lines like this by using the trim command. Okay, alright. Here my sketch is fully constrained, so we will quit the sketching mode. Save the part file. Now we will activate the revolve command from here and select the sketch. Now select the x-axis to specify the vector and click OK. See, my first revolve feature has been created on here. It is looking very nice. Next, we will create two legs of the motor part. So now we will activate the Datum Plane command from here. And create a new datum plane at an offset distance value 1.7322 inches inside direction from the front face of the model. We will resize the plane from here. Okay. And start the sketching on this plane. Now we will take the project of the entire model by using the intersection curve command and activate the section view command by selecting this plane. Now rotate the model in this position . And convert the entire sketches into reference geometry. Now we will create a horizontal line from here . The line dimension is 7.71654 inches. Now we will apply the dimension between the center point and this line. It will keep 3.937 inches. We will create 3 more lines on here like this. And convert the baseline into reference geometry. Create a horizontal line and a slanted line over the inside. Select this line and baseline and fix the angular dimension 30 degrees. This line dimension is 1.65354 inches. Now select this endpoint of the line and this point. Okay. And fix the dimension 0.3937 inches. Now we will apply the angular dimension 20 degrees between these two slanted lines. The height of the motor leg is 0.47244 inches. Okay, now we will create a mirror of these sketch lines on the opposite side by activating mirror curve tool like this. Create two center point arcs between these endpoints of the sketch profiles to close it. Now my sketch is completed, so we will quit from the sketching environment. Okay, now we will extrude this sketch region 5.8666 inches backside. Under the Boolean area, we will select the Unite option, okay, and click OK to create extrude feature. Okay, that's it. See, my motor leg is successfully created. Okay, alright, it is looking perfect. Now rotate the motor in the front side direction and create a new datum plane from the front face. Set the offset distance value 4.01575 inches. The new datum plane will keep on the back side and click OK. Now we will resize this plane. Okay, and start the sketching over this plane. We will take the project of the entire body like this. Okay, alright. And convert the entire sketches into reference geometry. We will draw the two vertical lines on the top side and apply the equal constraint between both lines. Now select these two endpoints of the lines and apply the horizontal constraint between them. Snap the endpoint of the lines over this curve by fixing the point on curve constraint. And fix the dimension 4.7244 inches between these two vertical lines. Now we will apply the vertical dimension 5.039 inches between the endpoints of the line. Okay, alright. Now we will draw the horizontal line over the end of the lines to connect it. And convert the line into reference geometry. Draw two horizontal lines over this reference line. Its line dimension will keep 0.59055 inches. Draw an arc on here. The height of the arc is 0.27559 inches. Draw another arc on this projected curve to complete the sketch. Okay, that's it. Finish the sketch. Now we will extrude this sketch 3.62205 inches symmetrically on both sides from the center plane. Okay, now see here my feature is created. Now we will change the color of the model like this. Okay, it is looking very nice. Okay, that's it. Save the file. Start the sketch on this face. Draw two circles on here. Select these two circles and fix the equal radius constraint between them. The circle diameter is 1.27953 inches. Draw the line over the center of the model. Okay. And convert the selected curves into reference geometry. Apply the dimension 3.070 inches between the center point of the circle and the horizontal line. Apply another dimension 1.65354 inches between these two circles. Okay, draw a horizontal line between these two circles. Draw a vertical line on the mid of this edge. And fix the point on curve constraint between these two lines. And trim this line. Okay, now we will quit the sketch. And extrude these circles 0.118 inches from the front face. Okay. Take a new datum plane from the XY plane. The offset distance value of the plane is 4.055 inches. And start the sketching on this plane. Now we will take the project of the entire body by using the intersection curve command. Okay, alright. And activate the offset curve command from here. Set the offset distance value 0.03937 inches. And take the offset of this rectangle inside here. Click OK. Exit the sketch and activate the extrude command. Select the sketch profile. Extrude the sketch 0.03937 by 2 inches both equal directions from this face. Okay, that's it. Now see, my slot is cut over the motor part. It is looking very nice. Now we will create another new datum plane at an offset distance value 0.62992 inches from the front face. And start the sketch over this plane. Now we will create one more slot on this cylindrical surface like this. Okay, now see. We will create the sketch on this slot face. And take the project of this circular edge. Now choose the front view. Draw two slanted lines like this. And fix the equal constraint between these two lines. Now we will activate the Symmetric Constraint tool from here and apply this constraint between these two lines. Now we will apply the angular dimension 30 degrees between these two slanted lines. Draw a 3-point arc over the end of the lines to connect it. Okay, alright. And its radius is 0.23622 inches. Now we will fix the point on curve constraint between the end point of this line and circular edge. We will fix the vertical dimension between these points. It will keep 0.25212 inches. Okay. The width of the arc is 0.45634 inches. Now we will create another center point arc on here like this to complete the sketch. So now my sketch is fully constrained on here. Exit the sketch. Extrude this sketch 0.59055 inches in this direction. And click OK. Now see my extrude feature is created here. In the same manner, we will create another same extrude feature on the opposite side of the slot face in the following way. The extrude distance is 0.51181 inches. And click OK to create extrude feature. Next, we will make a small hole over this extrude feature. Okay, so now activate the hole command from here and choose the general hole option. Fix the diameter of the hole 0.23622 inches. Now we will set the location of the hole where I want to create it. Okay, now select this face. Draw an arc over this circular edge. And snap the whole center point over the center point of the arc by using the point on curve constraint command. Okay, alright, quit the sketch. Whole direction will keep normal face. Now choose the until selected option under the depth limit section. Next, we will select the back face of the extrude feature and click OK to finish the whole command. Now see, my hole is successfully created on here. It looks great. Next, we will create a circular pattern of these two extrude features and one hole 4 times. Let's pick up the pattern feature command from here. Select this extrude feature and hole feature. Okay, in the rotation axis area, we will select the x-axis. In the angular direction area, we will choose the count and span option. The pattern count value is 4 and the span angle is 360 degrees and click OK. Alright, now my pattern feature is created here. It is looking very nice. Now activate the edge blend tool from here and fix the blend radius value 0.07874 inches. Now we will give the fillet on this circular edge of the motor like this. Okay, alright. We will activate the Datum Plane command from here and create a new datum plane at an offset distance value 0.19685 inches from the inside motor face. Okay, and start the sketching on this plane. Now we will take the project of this circular edge. Okay, activate the clip section view by selecting this plane. We will draw two rectangles on here. and remove the side lines of the rectangle. Now drag the rectangle like this. Okay, alright. Snap the end point of the rectangle lines on the projected curve in the following way. Now we will create a center line over the center of the motor part. And apply the vertical dimension 0.3937 inches between the center line and rectangle. The width of the lower rectangle will keep 0.70866 inches. The width of the upper rectangle will keep 0.69744 inches. The height of the both rectangles will keep 0.7874 inches. In the same way, we will create multiple rectangles on here like this that we had done previously. The dimensions will be given the same on the rectangles, but the distance value change between the rectangles. Here we will set the distance 0.43898 inches between these two rectangles. Similarly, all the rectangles we will create here will have the same dimensions. Now all the rectangles are made here. We create an arc one by one over each endpoint of the rectangles to close the sketch profile. Okay, that's it. My sketch is completed here. So now we will exit the sketch. Activate the extrude command and select the entire sketch. Set the extrude distance value 6.79134 inches and choose the Unite option under the Boolean area. Click OK. Now see, my grill of the motor is created. It is looking perfect. In the same manner, we will create one more small ventilation over the motor. Okay, so now we create a new datum plane at an offset distance value 0.19685 inches from this face. And install the sketch over this plane. And take the project of this circular edge. Activate the clip section view by selecting this datum plane. Now draw a vertical line from the part origin Draw 3 more lines on here. And extend it over the projected curve. Select this line and center reference line and fix the dimension point 27559 inches. Okay, alright, the rectangle height is 0.70866 inches. And its width is 0.07874 inches. Okay, alright, in the same manner, we will create 5 rectangles with the given dimensions on here in the following way. Now we will create an arc on each rectangles to close the sketch profile so that we can extrude it easily. So now my sketching is completed here. Quit the sketch and exit from the clip section view. Extrude the entire rectangles 2.44094 inches in this direction. Okay, now see my ventilation of the motor is made. Now we will create a mirror of the entire gratings of the motor on the opposite side of the part. Okay, let's see. Now we will apply the fillet on these four edges. Let's start the sketching on this face. Draw a rectangle on here and its width is 1.5 inches. Create the two circles on both sides of the rectangle. Now fix the dimension 0.40368 inches between the side edge and rectangle line. The circle diameter is 0.375 inches. And we will trim the inner portion of the circle like this. Okay, that's it. Finish the sketch. We will create a slot by selecting this sketch with the help of extrude command. Now activate the pattern feature command and select this extrude feature. Here we have selected the linear option under the pattern definition area. Select the side edge of the motor leg to specify the vector. Choose the count and span option, set the count value to and fix the span distance value 3.5 inches. Here we will select the use direction to option so that two more similar slots are made on the opposite side of the motor. But this time the span distance value will keep 6.5 inches. Okay, that's it. Now see the result. Now my motor is completed on here. Close the par file. Next we will create its shaft on here. Okay, alright, it is an inch part. Save the part, name it as shaft motor. Now we will pick up the sketch tool and select the XZ datum plane to start the sketching. Draw a horizontal line in the design window and its length is 14.5 inches. Select the center origin of the part and midpoint of the line, then fix the midpoint constraint between them. Now we will fix the collinear constraint between this line and x-axis. Draw the three lines from the end point of this horizontal line, something like this. And fix the dimension 0.75 inches over this line. This line dimension is 3 inches and this line dimension is 0.375 inches. Create another line on here, its length is 7.5 inches. Now we will draw some more lines with the given dimensions to close the sketch profile. Okay, alright, finish the sketch. Activate the revolve tool and select the sketch and click OK to create revolve feature. Now we will activate the true shading button and change the material of this part. See, my shaft is looking perfect. Now we will activate the chamfer tool and choose the offset and angle option. Fix the chamfer distance 0.1 inches and apply the chamfer on the front edge of the model. Activate the edge blend tool from here and apply the fillet on this circular edge. The fillet radius is 0.1 inches. In the same manner, we will apply the chamfer 3 more edges of the shaft. Next, we will make a small key over the cylindrical surface on the shaft in the following way. Okay, that's it. My shaft is completed here. Close the part. So now we will create a new inch assembly file in Siemens NX. And set the name of the assembly AC motor. Click OK. See here, the add component command has already been activated in the assembly design window. At first, we will place the AC motor in this assembly. OK, now select this file and click OK to place the part. See on this dialog box, it will ask you that it is the first part that you placed in the assembly. Do you want to fix it? Click yes button. Okay, that's it. Now we will hide the visibility of the entire visible work planes and sketches of the part by using the show and hide button. Now we will enable the true shading button so that my assembly can be visible much better. See, the motor part is looking perfect in this assembly. Now we will place the shaft by using the add component command. Rotate the assembly in the front side direction. Now we will activate the move component command. Now drag and rotate the shaft in this position like this. Okay, now we will activate the assembly constraints command. We will choose the infer center axis option in this dialog box. And then next, we will select the axis of the shaft. Okay, the whole axis of the AC motor. Okay, and apply the axis made between them. Now drag the shaft in the front side direction. We will apply the distance constraint between the front face of the motor and shaft part. The offset distance will keep 2.738 inches between these two faces. Okay, that's it. Here we will check the degree of freedom of this part. Now we'll activate the show degree of freedom tool and select the motor part. See, there is no degree of freedom on this part because the fixed constraint has already been applied. Select the shaft part. See, the shaft is rotating on here its axis. Finally, my AC motor assembly has been completed here in Siemens NX. I hope you will enjoy this video. If you may like this video, please like and subscribe to our YouTube channel. Please share this video with your friends and colleagues. So now I will meet you in our next video. Okay friends, goodbye.